on YouTube for later viewing if you wish. So, we start with this. Arithmetic, right? What is that? That was our last unit, was arithmetic. Which is working with numbers, okay? Okay? And numbers have different forms, right? There's the whole number. There's the fraction, which is just a number in between two whole numbers, right? There's the decimal, which is basically a fraction. There's the percentage, which is also just a fraction, or something that's not a whole number. We know through arithmetic that there are 4 basic ways you can manipulate: multiplication, division, addition, and subtraction. Hopefully, your 8 years of public school education got you to a point where you feel fairly confident with arithmetic. Some of you tested in the first unit that this wasn't quite confident in some ways, specifically some of the little specific ones like fractions and decimals and stuff. But we worked on that for most of this course. We worked on trying to get your skills where they should be. And now when you get to the end of learning arithmetic, you need to actually apply math to something real, okay? And at first this seems like an abstract concept. But the word that generally describes this is the word algebra. Okay? Algebra is arithmetic with an unknown. Okay? So this is the real life application, right? Often we use math to figure out things that we don't know, like how much we should tip the pizza guy, how much lumber we buy when we go to the store before we build our fence. What's the best price out of these 2 cars and these 2 car dealerships? This is the life math that you're not going to be able to avoid. You can avoid listening to me. You can avoid going to math class. But you are not going to be able to avoid this in your life until your life is no more, right? And even then, you might have to figure out which coffin is the best price. Oh, that's kind of grim here on this Tuesday morning. But that's the reality. And this unknown is essentially what we learn next, which was the concept of a variable. A variable is the unknown, okay? But in math, we start to write things slightly differently. So the second we start getting into algebra, the way we write math changes a little bit. Because up here we were able to use these good old 4 symbols. We were able to, use digits 0 through 9 and combine them. But now that we have variables, we have to now start using letters. Well, we don't have to, but that's the way it's going to go, okay? At first, when you first learn about variables, you can use symbols like a box or a triangle. But eventually, your math gets to the point where we're going to use letters to represent the unknown things, okay? So that's where we're at. And then once we start working with this, we start working with words like equation, okay, which is just algebra with an equal sign in it. Oops, let's draw that a little bit better. That's where equation, equal comes together, okay? And at first, this is easy if I just say to you, oh, well, here's what the unknown is. You know, x plus 5 equals 10. Oh, well, x is 5. There, you know what the unknown is. But when it becomes an equation, very often what we're looking for with the unknown is the solution. We want to solve our algebra. Just like when you're figuring out the tip, you are solving for that unknown thing. And that's what the last 4 classes have been all about. Solving algebra equations, which, by the way, would be more sort of indicative of the way a grade 9 teacher would describe a unit. The unit actually often has more complex names than that. If you've seen the grade 9 math, it says things like linear equations, okay? Which even makes it even more difficult to understand, but that's what it essentially means. It means looking for the unknown when you don't know what it is. And in our study for this, there's been a couple key words that have come out. Balance. Okay, what you do on one side, you do to the other. Opposite. Okay, otherwise known as inverse. Okay, which is if I want to get rid of something, I do the opposite to it, right? So if I want to get rid of a +5, I use a -5. If I want to get rid of multiplication, I use division, etc. I always do the opposite. Okay, isolate. Or being alone, which was what we focused on last week. That's the goal, to leave x, or the unknown, by itself on one side, and the answer on the other side, to keep the balance. And that's where we've got to with algebra. Okay, you can hopefully start to see that all this seems like math class. But eventually, all this sort of working with x's and numbers and stuff has to become more real. Okay? And it becomes more real when we take the world of math, and specifically the language of math, and relate it to the real world language. And be able to go back and forth in a process that you could call translating. Just like we do here in the school with French versus English, we translate, okay? We turn the real world language into the math language. So how are you going to see real world language? Well, in math class, the way you're going to see real world language is through what we typically just call word problems. And that might have been scary to you guys, just seeing me write that down. And I know that because when I tested you guys on word problems before we started this unit, little to none of you actually did a word problem. It's been probably one of those types of math questions that have stumped you for years. It certainly might have stumped you in the grade 9 course, because you see a word problem and you just give up. I'm done. Can't do them. Okay, but really think about what they are. Word problems are our attempt to write something in real world language and then be able to translate it into math language so that we can use something to solve for the missing piece. And that's what you're going to be doing today. Okay? All right. So let's get started with it. Okay. So as I just said, last time we really worked on solving. And we finally whittled down our method of solving algebra equations to a nice 5-step process. Okay? Some of you were working on this in the last assignment and actually doing it step by step. And I said there are even easier ways to think of these 5 steps. Okay? At the shortest, you could just use what most math teachers call it, the inverse operations. But that might be too confusing to you. So then we had that idea of just thinking that, you know, you remove the brackets, and then you do the opposite, and then you keep balance, and then you find it isolated. Remember Bobby, B-O-B-I, another way to think of it. Okay? Then there was a bobic, where we had the first step, the arithmetic, and the final step to check it. All of those might be useful to you if you practice them. Okay, so today I'm going to teach you one alternative way to do it. For those of you who really think lazy and don't want to do all those steps, but might feel confident enough to do it this way, this method I'm going to show you today kind of skips a few steps. Now, if we're just solving puzzles, and the variable is the unknown piece, and we're using all this language, okay? The central goal still is to solve puzzles related to the real world, okay? So we've been trying out these techniques, this inverse operations technique or method, but you sometimes get lost in it. You think, well, this is just math class, math class, math class. You lose the fact that it is going to relate to the real world eventually, okay? So if we start with the method I first showed you, the guess and check, that's only going to get you so far in the real world. If you just constantly guess, you are going to get ripped off when you buy that car. You're going to have someone spit on your pizza because you didn't tip them enough. That's a gross example, I know, but you get the idea. You are not going to be able to solve those problems. So you can't just guess. You need a better method, okay? Now, I've taught you a method, Some of you use pieces of that method now as you're solving it. Some of you may not, for example, draw a line through the equal sign like I've shown you. Some of you may not draw a little teeter-totter under the equation to help you understand balance. Some of you might be able to still draw those to help really emphasize the fact that this is balance and that one side, the left-hand side, equals the right-hand side. Okay? To a math teacher, it doesn't mean you have to do it this particular way, but to a math teacher, when they're marking your math, they need to see a way. If you just write down 5 on your sheet, even if you get it right, you're most likely not going to get 100% on that question, because we want to see you demonstrate the way you got to that answer. Okay, that's the reality. That's the reality of the math that you need to do. Okay? Now, when you take the grade 9 math course, you're going to get even more methods. Like, for example, one that I think a lot of us will groan when you hear, the idea of using algebra tiles. Okay? I am not a fan of algebra tiles, but the reality is they work for some people. Okay? Not me, but for some. So you can't avoid them. They are part of the grade 9 course. They're in the grade 9 textbook. They're in the grade 9 curriculum. And if you think you're not going to get them, you're living in a world that doesn't exist. Okay, but the way I want to teach you today is called the cover-up method. It's probably the easiest way I could possibly describe solving this. Basically, what you do is cover up the thing you got to solve. So here's some algebra. 60x plus 50 equals 300. So what I do is I use my finger or my hand or a book or a cup or whatever, and I cover the thing I'm trying to solve. And now I just use mental math. What plus 50 equals 300? Can anyone do that mentally? What is it? 250, right. So the thing I just covered up gets rewritten. So that thing I was covering up, which was the 60x, gets rewritten. And then the 250, which was the answer that Phoenix correctly gave us, gets put on the other side. And I continue this cover-up process. Let me give you a better example. Here's one. X over 5 minus 1 equals 1. So what I do is I cover up as much of this as I can. Now if I cover the whole thing, then I just say, well, what equals 1? Well, 1. So that doesn't give me anything. But I could cover all of this. I could cover all of this right here. Just cover it all. And I could do the mental math. What minus 1 equals 1? No, not 0. What is it? What is it? David, say it. Say it. What's your question? You can't divide by 0. When you say what happens, do you mean on a calculator? Or with your pencil and paper? The calculator gives you an error. If you do it on pencil and paper, you get it wrong. Well, I can explain it in more detail later, but basically, if you do it on a calculator, the calculator gives you an error. If you do it on a piece of paper, you get the question wrong. Okay, so it's 2. 2 minus 1 equals 1. So then I just take the 2, and I write it on the one side of the equal sign, and the thing I was covering up, that, gets put on the other side of the equal sign. And then I do it again. Now I go, okay, I'll cover the x this time. What divided by 5 equals 2? Anyone? What divided by 5 equals 2? Well, it must be 10. 10 divided by 5 equals 2. And I'm done. So the cover-up technique is a lazy technique, but it only works well if you can do the mental math. Okay? If you can't do mental math, cover-up technique doesn't work well for you. I'm presenting it as one last option for you guys, as a way to integrate this into the sort of manipulation of algebra that you've been working on. Okay, but I have to warn you about percentage questions. They're probably some of the more tougher algebra questions. Now, we learned in the last unit that percentages, or percents, are just fractions. Okay? And actually this relates to your question, David. Fractions are just division. So when you say, why can't you divide by 0? That's also saying, why can't I make a fraction with 0 on the bottom? Yeah? So why can't you? A fraction represents on the top the number of parts you have, and on the bottom, the total number of parts. So what you're putting on the bottom, when you put a 0, means you have 0 parts. So you're talking about nothing. So that's why you can't divide by 0, because you can't talk about something with 0 parts to it. Right? If you say, well, I have a pizza with 0 parts, you don't have a pizza. You got nothing. Okay? So that's why you can't divide by 0, because it's not a fraction and it just doesn't work. Okay? In the real world, percentages probably come up more than any other piece of math. That's how the taxes you pay work, which you will pay and do pay. That's how your paycheck works, is it works on percentages. Okay? That's how you sharing with your friends works, is based on percentages. That's how your math mark works. It works on percentages. So percentages are in the real world all the time. Okay? Even when you grab a coffee and you figure out what percentage of that coffee is caffeine, or let's say it's some other thing you're eating or drinking, and you're figuring out perhaps what percent of fat is in it if you're watching your girlish figures like me, right? Then you got to think about these things. They are percentages. But percentages get tricky. So for example, what's 20% of 45 would be a typical percentage type question. And how do you work with that? How do I actually solve that? That's a very simple percentage question that right away might have stumped you. How to work with a question like that. Very common, right? Well, the word of is the hint. The word of tells you a little bit exactly what's going on. It's what I was talking about here a little bit before. That we are translating real world, the word of, into something in math. So it makes a little more sense. Okay? So it's some clues. So here's a couple clues you can pick out of real world. So when you see sum of, or take away, or product of, this and, difference, opposite of, share the. These relate to words and ways you can manipulate the math. And the word of is a percentage question that relates to multiplication. We'll get to that in a second. So for example, if you had $45 and you said to your friend, I'm going to give you 25% of this 40. Say you guys did a little job together and your boss paid you 45 bucks. And you said to your buddy, you know what, I did most of this work, but I'm going to give you 20% of this money that we got from our boss. How much money are you going to give him or her? If you don't know how to work with this question, you might not only be giving him too little money, you might be giving him too much money. And that's your money. You don't want to lose that. What's that? Yeah. So the word of means multiplication. So really, what we're doing here is multiplying. But how we do the multiplication is a couple different ways. 20% times 45, that's not going to work. You can't multiply a percentage. You can multiply a fraction, but fractions can be tricky. Decimals, though, are easy to work with, because 0.2 times 45 gives you 9 bucks. But you needed to know that 0.2 is 20%. And you would have known that from the last unit we did where we converted decimals into percentages and percentages into decimals, into fractions, etc. So here's what I'm saying to you guys. The real world comes up in math, not in math class. The real world comes up in math. And if you don't have these skills, you are putting yourself at a disadvantage. Okay, so let's wrap today by finding a way to work with word problems. Okay? So translating translating the real world into math is actually where the word expression comes from. You are expressing yourself in math. Okay? Everything on the left-hand side equals everything on the right-hand side. That's what an equation is. Okay? This is what the algebra works with. Word problems come up with sentences. As you read the sentence, here's my advice for how to deal with word problems. Okay, we're going to do 2 examples with this. First, pay attention to the clues. So when you read a word problem, just read it the first time to try and drink in what it's asking. 2, it's a math problem. So highlight, underline, whatever, numbers in the math problem, in the word problem. Sometimes the numbers are actually in their symbol form. So like an actual 3 symbol. Sometimes they'll write them in words, like the word 3. Doesn't matter. Highlight the numbers. 2, watch out for key clues like we just talked about. So if you see sum of or product of or something like that in the write-up or more than, that indicates that some math is happening. Then figure out what the final question is asking for, highlight that, read it again, and then turn it into algebra. All right, let's give it a shot with an easy one. Jane and her 3 college friends are going to share the cost of a 3-bedroom apartment. The cost of the rent is $600. What's Jane's share? For a lot of you, you can do this question just with guess and check. Anyone have an answer at this point? What's Jane going to pay? This, by the way, will be probably a problem some of you will have to deal with in just a few years. Unless you have the money to buy your own house, you might be renting. And you might not be able to afford the rent on your own, so you might ask some friends to rent with you. Now, if your friends know math better than you might be paying more rent than you should. So what would Jane pay? How much rent does she pay? Any idea? Can you guess at this point? No one can guess? 200? Okay, good. Let's work it out, though, using my process, my method. 1, we read for clues. 3 friends sharing means they all divide it up. The word sharing essentially means dividing, okay? The unknown is what Jane pays. That's our unknown thing we're looking for. Step 2, highlight the numbers. This is why I often suggest bring a highlighter to math class. Yes? The bell rings in 5 minutes, so I want to get through this. Okay? There I've highlighted the numbers. Next, highlight math operations. So the word sharing means dividing, so I'll highlight that. Next, highlight the final question. This is what we should be answering. So now I've stripped away the stuff that doesn't matter, and I can focus on the specific important things in this question. Now I got to turn it into math. So R is the rent, J is Jane's share. I know the rent is actually 600. So 600 divided by 3 is 200. You were right. And that's the final answer. Jane's share is $200. She did it with guess and check. Let's see if you can do this one with guess and check. Mary bought a soft drink for $2 and 9 candy bars. She spent $47. How much did each candy bar cost? Anyone do that one with guess and check? Let's work it out. Read the problem. 2, highlight any numbers. So I highlighted the numbers. 3, highlight math operations. So and means things being added together. Total means things being added together. Focus on the final question. How much did each candy bar cost? Let's write down some math. We know that she paid $2 for 1 soda and an unknown number of candy bars. If she took all those, the total was 47. So if X is the price of candy bars, $2, that's the soda, plus 9 candy bars, we don't know how much they cost, okay, equals $47. Subtract 2 from both sides, divide by 9, X equals 5. The final answer, Mary paid $5 for each candy bar. This takes practice, but what I'm giving you now is a 7-step method for working with word problems. However, embedded in step 6 is how to solve the algebra, which is the one we started with today. Okay? So basically today what I'm giving you is some language that relates to word problems and a method that you can work with word problems. And you'll get an assignment tomorrow that works on this. Okay? Is there any questions?